Girls, you have seen about amplitude shift keying and frequency shift keying. Now let us see what is phase shift keying, PSK. Now in ASK we learned that amplitude will be varying. In FSK we learned that frequency will be varying. Now in phase shift key we will see what will happen. Phase shift keying is a digital modulation technique in which phase of the carrier signal is changed by varying sine and cosine pulses at a particular time. This technique is widely used for wireless LANs, biometric, contactless operations, along with RFID, radio frequency identification, and Bluetooth communications. PSK is of three types depending upon the phases. The signal gets shifted. The three types are BPSK, binary phase shift key, QPSK, quadrature phase shift key, DPSK, differential phase shift key. Now we will consider about binary phase shift keying mainly, because as we are doing with the digital communication technique, it is important to know BPSK deeply. Okay, BPSK is also called as two-phase PSK or phase reversal keying. Why we will see in the later slides. In this technique, the sine wave carrier takes two phase reversals such as 0 and 180. It is basically a double sideband suppressed DSBSC. Modulation scheme for message being the digital information. The full form for DSBSC I was unable to search. Actually, I forgot. I will let you know in the group. Modulation scheme for message being the digital information. That means for this modulation scheme, message will be in the form of digital codes. Now next one, QPSK. This is a phase shift keying technique in which sine wave carrier takes four phase reversals, that is 0, 90, 180 and 270. If you observe, for binary, two phase shifts. Oh, just wait now. Just a second. For binary phase shift keying, the shift reversals are 0 and 180. Quadrature means 4. So in this case, the four phase reversals are 0 to 270. It is the kind of, if this kind of techniques are further extended, PSK can be done up to 8 or 16 values, also depending upon the requirement. That means more than 16 can also be performed. Now, BPSK modulator. The block diagram of BPSK consists of balanced modulator, which has the carrier sine wave as one input and balanced binary sequence as another output. See, binary sequence, carrier is one output and binary sequence is another output. The modulation of BPSK is done using a balanced modulator which multiplies two signals applied at the input. For a 0 binary input, the phase shift will be 0 for a high input and the phase reversal will be 180. The output sine wave of the modulator will be direct input carrier or the inverted 180 phase shifted input carrier, which is the function of data signal. Now in this case, if you see, just observe the output. Phase is exactly reversed for 180 degrees or 90 degrees. Okay, see, at every dotted line you can see phase is reversed. Okay, This is the only point you have to remember in case of PSK. Now BPSK Modulator. Now here in this case and in this case there are few differences. It will have mixer with local oscillator circuit and a filter, along with that a 2-input detector circuit. By recovering the band limited message signal with the help of mixer circuit and band pass filter. What is saying? By demodulating the band limited message signal with the help of mixer circuit and band pass filter, the first stage of demodulation gets completed. The baseband signal, which is band limited, is obtained, and this signal is used to regenerate the binary message bit stream. You can observe the tables. Carrier and BPSK are multiplied here. That is passed to a BPF. The output of BPS is given to detector along with clock, which produces a output. In the next stage of demodulation, the bit clock rate is needed at the detector circuit to produce the original message signal, which is in binary form. If the bit rate is submultiple of the carrier frequency, submultiple means if the carrier frequency is 20 Hz, submultiple 30, 40, like that. Then the bit clock regeneration is simplified. To make the circuit easily understandable, a decision-making circuit may also be inserted at second stage of prediction. Here you can see stage 1, stage 2, he has mentioned already. Now QPSK, it is a variation of BPSK and it is also called as double sidebanded suppressed carrier. I think this is the full form of DSPS. In this modulation scheme, it sends 2 bits of digital information at a time. The information is called bidits. This is not digits, it is bidits. Instead of conversion of digital bytes into serial of digital system, it converts them into bits. This decreases the data bit rate to half, which allows space for other uses. Now, if you observe QPSK Modulator, you can see all the different blocks which I spoke about. Two multipliers, PSKI, PSKQ, digital data. Now output block contain is interlinked with 2 multipliers. The 2 multipliers are interlinked with the digital data. You can see the digital data contains even on odd bits, and that block is called bit splitter. Okay, if you observe, it is also written as 2 bit serial to parallel converter. You know what is different? What are the different shift registers? In that, here he is using 2 bit serial to parallel converter. And one more thing is, you can see a block called phase shifter in between 2 signals, I and Q. That means, first, depending upon the digital data, it will convert the serial data into parallel. All bits are connected to the second block, even bits are connected to the first block. Depending upon the even or odd bits, what will happen? This block will split the bits either to PSKI or PSKQ, and both will be phase shifted with this block. After the bit is phase shifted either to 0, 190 or 890 or 180, depending upon the model, carrier will be added and output is given to this block to generate the final output. Here in this case, you can observe, wherever there is a dotted line, there you can see a phase shift. But first is a different phase shift, second is a different phase shift, third is a different phase shift. Now that phase shift is dependent on the value. You can see a 00, 10, 01, 11. Now this will be generated by this bit splitter. Okay, this is about demodulator. This is modulator circuit. This is demodulator circuit. You can see this blocking modulator present at the input side. Here it is present at the output side. Now these two are integrators. These two are filters, and remaining one are sum. Phase of modulated signal is shifted relative to the previous signal element, and no different signal is considered here. The signal phase follows either high or low states of the previous element. This BPSK technique does not need a need difference oscillator. That's why in the case of modulator, there is no oscillator. Now, the model sequence waveform will be like this. Depending on this data, frequencies shift, phases shift. Now in this case, amplitude is constant and also frequency is constant. After this point, and the last one is nothing. This picture depicts modulator of BPSK. If you observe, there are only three blocks: X0, 1 bit delay generator, and a multiplier to multiply output of node, 1 bit delay, and a carrier to produce BPSK. This is the demodulator. In demodulator, the only difference is instead of this XNOR gate, he is adding LPF, low pass filter, and a shaper. Always remember, wave shaper will always be made out of any one of the diode. Okay. In the first slide, like here, I have told phase shifts are divided into three: BPSK, QPSK, and DPSK. I explained BPSK and QPSK in detail, if you observe. But whenever I come into BPSK, I have given only the figures. I just defined BPSK in few words, and I have given different figures. So what you do is, if you are able to learn BPSK and DPSK, it is okay. Or else you learn BPSK perfectly along with the figures, then you simply define QPSK and DPSK and draw the figures. Figures in the sense modulator circuit, model waveform, demodulator circuit. Similarly for DPSK, model circuit, this is the model circuit, demodulator circuit, and a model waveform. This is more than enough for PSK because it is a prolonged topic. There are different types, and again in each type you have modulator, demodulator circuit, and also the figure. Okay, so it is better to learn BPSK perfectly. BPSK and QPSK, you just write the theory in a few lines, 1 or 2 points, or more than 3 points, and draw the figures perfectly. Okay, BPSK, you explain each and every point clearly. Okay guys, thank you.